Today we're on page 3 of our Chapter 12 notes packet. We're going to continue to work with the formulas for the sum and difference of two angles today, but in a slightly different setting. Yesterday, when we worked with the sum or difference of two angle formulas, our angle measures were actually just that, angle measures, okay, like the 270 plus the 30. Well, here, the angles are going to stay as variables. So in other words, sometimes the two angles are variables like A and B, or X and Y, and these angles will be in different quadrants. They are not drawn in the same triangle. There is usually no specific mathematical relationship between them. Sometimes you'll be given one trig value of each of the two angles. So instead of being given angle measures, we're going to be given one trig value of each angle. It's then our job to find the other trig values that are not given by simply going back to chapter what we did in chapter 9 and 10. Draw a triangle, use Pythagorean theorem, and then SOHCAHTOA. So we look at number 1 here. It says if sine of x is equal to 4/5 and the cosine of y is equal to 4/5. Now these are two different angles, and x and y are in the first quadrant. Find the value of sine of x plus y. Okay, well, sine of x plus y, sine of a plus b. So get it from the formula above. So sine of x plus y is going to be equal to will equal sine x times cosine y plus cosine x times sine y. Now, the sine of x is 4/5, and these are both in quadrant 1. So I would draw a right triangle in quadrant 1, right? Make sure you label this angle x. Sine is opposite over hypotenuse, so opposite 4, hypotenuse 5, and then the adjacent side would be 3. This is a 3, 4, 5 right triangle. And now the cosine of y, y being a different angle from a different triangle, although it is in quadrant 1, it's going to look the same. Make sure you label this y. The cosine of y is 4/5, so adjacent side is 4, the hypotenuse is 5, and again this is the Pythagorean triple 3, 4, 5, so the opposite side is 3. Opposite, adjacent. Okay, so now the sine of x, just make sure you're looking at the correct triangle. The sine of x is the 4/5. So replace sine of x with its value 4/5 times the cosine of y. The cosine of y, okay, is 4/5. It's adjacent over hypotenuse. Plus the cosine of x, going back, cosine of x, 3/5 times the sine of y. The sine of y, 3/5. Multiplying 16/25 plus 9/25 is equal to 1. Number 2, angle B is acute, and the sine of B is 12/13. Find the value of sine of 90 minus B. Okay, the value of sine of 90 minus B, this is sine of A minus B, so we're looking at that formula. and we'll replace A with 90 degrees, and B would remain B. So the sine of 90 minus B is going to equal A minus B sine A cosine B. So sine 90 cosine B minus cosine A cosine 90 times sine B. All right. Well, sine of 90 90-degree angle, quadrantal angle, coordinates of the point 0, 1. So the sine of 90 is 1. So we have 1 times the cosine of B. Right? We were given the sine of B. And B is an acute angle, so that means it's in quadrant 1. So we'll draw a right triangle in quadrant 1. Label this B. Sine is opposite over hypotenuse, so that's opposite over hypotenuse. That's 12, 13. This is a triple. This is a 5, 12, 13 Pythagorean triple. If you didn't recall that, then we would have to simply do a squared plus b squared equals c squared. So a squared plus 12 squared equals 13 squared. That's a squared equals, that's 169, subtract the 144 is going to be 25, so a is 5. All right, so we have opposite, adjacent, hypotenuse. So the cosine of B is adjacent over hypotenuse, so that's 5/13. The cosine of 90, that's the x value, 0. 0 times anything is going to result in 0, but sine of B is 12/13. So multiplying, 1 times 5/13 is 5/13, minus 0 times 12/13 is 0. So the value of the sine of 90 minus B is 5/13. Number 3, if sine x equals 3/5 and x is a measure of a positive acute angle, right, let's stop right there. Sine of x is 3/5 and we have another positive acute angle, so we'll draw a right triangle in quadrant 1. Sine x, label the angle x, opposite over hypotenuse, so the adjacent side is 4, that's a 3, 4, 5 Pythagorean triple. Do you have to draw the triangle? No, not every time. I know that a lot of you, if you know that the sine of x is 3/5, 3/5, then the cosine has to be 4/5, right? Find the value of the cosine of x plus 180 degrees. Okay, so this is the cosine of x plus 180. This is the cosine of the sum of two angles, A plus B. So we look at our formula above. The cosine of A plus B is equal to cosine A cosine B minus sine A sine B. So replacing A with x, we have cosine x times cosine of B, replacing B with 180, cosine 180 minus sine x times sine 180. Cosine of x is 4/5 times the cosine of 180 degrees, 180 quadrantal angle, -1, 0, so it's the x coordinate, -1, minus the sine of x is the 3/5 times the sine of 180. Sine of 180 is 0. Multiplying negative 4/5 minus 0 is simply negative 4/5. Okay, and let's do one more on the back. On page 4, we have the sine of A equals 5/13 and the sine of B equals 5/13. Angle A is in quadrant 2 and angle B is in quadrant 1. Find the tangent of A plus B. You know what? We'll hold off. Last night's video was much longer, so let's stop here and we'll pick up with this with tomorrow night's video. Thank you.